outcomes, intermediate outcomes, and long-term outcomes. And then beyond the expectation that the program, beyond the expectations that the program would lead to those groups of outcomes, we also tend to show a connection, or if I can use the word progression, from short-term outcomes to long-term outcomes. So again, the simple example I have today is specifically focusing on that progression from short-term to intermediate to long-term outcomes. I want to touch briefly, without getting into the technical details, of why SEM, structural equation modeling, is a good or let me say useful tool for verifying logic models. So apart from being a statistical tool for testing how programs work, it offers two specific advantages that I'm going to be discussing. The first advantage is that we can actually simultaneously conduct outcome and process evaluation using the same model. So by outcome evaluation, I'm referring to the typical assessment of direct effects of program on outcomes. And then by process evaluation, I'm referring to the opportunity to test mediation and moderation and moderator analysis. So mediation analysis typically refers to mechanisms of effect. That's how a program works. And the moderator analysis refers to the conditions of effect, for whom and why does the program work. And the best tool or textbook I ever found with explaining SEM and hierarchical linear model has the title that says, "It's all regression." So even though the name says structural equation modeling, it sounds technical, but at the end of the day, it's just a bunch of regression. It's just a lot of simultaneous regression analysis happening at the same time. So, but we will not be getting into the details of that. The second advantage here is the plausibility of program theory in real life. So in addition to examining those, what I would call regression effects, different types of interactions and direct or indirect regression effects, SEM also allows us to estimate model fit indices. And simply put, model fit indices are just indices that tell us if the model is really possible in real life and specifically in our data. So it's one thing to say in our logic model that we expect knowledge to lead to behavior change, but that may not be happening in real life. And how do we know if that is happening in real life? We use model fit indices to examine that. So those are the two broad advantages, in my opinion, that I think SEM has over other existing tools. So I'm going to go straight into the example that I have for you. This is an example from an adult nutrition education program. I understand that Cypher is a youth education program, so I'm not going to be boring you out with the details of this program. I just want you to know that the program teaches limited resource adults about how to plan nutritious meals on limited budgets. It teaches safe food handling practices and, of course, food preparation skills needed for a healthy lifestyle. And it's not just a curriculum, it's a curriculum plus series of wraparound activities like food demonstrations and provision of reinforcement materials. If you have questions about the program, we can chat later, but I don't, in the interest of time, I'm just going to go ahead and leave it at this. So what I have here is a very simple logic model depicting an aspect of this program. This is very similar to the Kellogg type logic model. So as you can see, we have the inputs, the activities, outputs, and the tiers of outcomes. And again, this is an abridged logic model. It's not the entire logic model for the program. So for this program, for example, activities include training the nutrition assistants who implement the program, recruiting participants, and of course, delivering the curriculum. And it is expected that participation in this program would lead to enhanced nutrition knowledge, enhanced food resource management skills, which is basically the ability to manage your monies, your food resources, food financial resources, And then we also expect that the program will lead to enhanced diet quality. So beyond the expected direct impact of the program on each of these outcomes, it is also expected that there will be a form of progression where the knowledge gained from the program will be used to enhance behavior changes. First, enhance food resource management skills, which will in turn produce enhanced diet quality. And in the blue box here, I have summarized the overall assumption guiding SNAP-Ed programs in general. And that assumption is that when participants go through the program, they are likely to learn the skills that they need to make healthy food choices within a limited budget. So the assumption of the program itself indicates that food resource management should be a mediating variable between participation in the program and the long-term outcome of enhanced diet quality. So transforming this logic model, this simple logic model, to a structural equation model, we have the blue model that's on the screen. And as you can see, this is again very simple delineation of what is expected. And the key question being asked here is, how does the program impact diet quality? And it's just a delineation of what we think should be the logical and sequential links among some of the program outcomes. And you will realize that I don't have knowledge on this as part of this model. I just wanted two quick variables that can be used as a simple illustration. So this model can be complex as we want it to be, but for today, we are just sticking with those three variables. And of course, for this model, we also controlled for race, age, education, and gender. I'm going to talk specifically about the hypothesized relationships. So as you can see in this model, we are expecting the direct effect of program participation on food resource management skills as well as diet quality. So that will be P1 and P2. And then we are expecting that food resource management would also enhance diet quality, that is P3. So in addition to those three direct effects, we also hypothesized a mediated effect where food resource management comes in between program participation and diet quality. And then altogether, the model says that the total effect of the program on diet quality will be the addition of the direct effect P1 and the indirect effect P2, P3. So in reality, that indirect effect is just a simple multiplication of the regression coefficient P2 and P3. So as simple as this model is, we have 5 assumptions. And of course, we are ignoring the control variable part of it for this presentation. So this particular model, because of the question we are asking, require data from an experimental or a quasi-experimental study. I'm not going to go into the details of how we matched the sample because it will take a lot of our time, but I'm going to say that the sample came from a propensity score matching that was done to link 8 comparison counties with 8 intervention counties that were matched on the basis of population, number of SNAP recipients, total poverty rate, child poverty rate, and the percentage of the county that is rural. And then for the final sample, we had 396 intervention participants and 111 participants in the comparison group. And the statistical analysis involved in the propensity score matching showed us that the groups are not only similar in terms of the matching variables, but also in terms of age, gender, education, and baseline scores, meaning that we didn't find any statistically significant differences between the two groups in terms of age, gender, education, and baseline scores. And I do have additional information about demographic characteristics as appendices to this slide, but I'm going to skip over that so we can get to the meat of the discussion. But if you have questions about that after my presentation, I can show those slides. So instrumentation and measurement of variables. Like I said, we controlled for demographic variables. So participants in both groups completed a demographic survey at program entry. And then to measure food resource management skills, they completed a 5-item survey that is part of the FNEP checklist. And that survey has good reliability, as you can see on the screen. Examples of items in that survey include how often do you plan meals ahead of time, compare prices when you shop, and how often do you shop with a grocery list. And then for diet quality, that was measured using a 24-hour food recall using the USDA multiple pass method. So participants were asked to list the type, the size, and all the condiments and everything related to the meals they consumed 24 hours preceding data collection. So that data was inputted into WebNairs. WebNairs was developed by the USDA. It has an inbuilt algorithm that converts the foods reported and the sizes into an index called the Healthy Eating Index. So the HEI, is a measure of diet quality. It ranges from 0 to 100, and higher scores typically indicate closer adherence to dietary guidelines. So let me go on to talk about the analysis. So for this example that I have, we conducted the analysis in 2 steps. First, the typical black box outcome evaluation test, where we conducted t-tests to compare entry, exit, and gain scores between the groups. And then we took it a step further to test the hypothesized model. And again, like I said, there were 2 goals for the models. One is to look at the model fit, to answer 2 questions. Are these hypothesized relationships plausible in real life and in our data? And does this model fit the particular data that we have? And on this screen, I have examples of indices of model fit that we consider to know whether the model has passed this test or not. And then the second aspect of the model, like I said earlier, is to look at the parameter estimates of the direct and indirect effects. And of course, not only the estimates, but to also look at the directionality of the paths. So in the model I showed you, we expected all the effects to be positive. It's very possible that we go and analyze the data and the effects are not positive. So we did look at the directionality. And in addition to statistical significance, we looked at practical significance. As much as I don't want to go into the technical details, I'm going to talk a little bit more about the measures of effect sizes here, because they will help us to understand the beauty of the model. So for the direct parts, we looked at effect sizes as semi-partial correlations, and that is just the relationship between 2 variables holding everything constant. But where I want you to pay attention is the effect size of the mediated path. So what that tells us is the percentage of the total impact of the program on diet quality that is mediated by food resource management skills. So this is actually, the measure of effect size here is actually the meat of the analysis for this simple model. We want to know to what extent does FRM, food resource management, mediate that relationship, and how much of it is mediated. So when I share the findings, you will remember this. So let's go on and talk about the findings. So with regards to our black box evaluation, we found, as expected, that the intervention group reported a higher level of pre-post gains, if I can say it that way. But I think a better way of saying this is to say that the intervention group increased in food resource management skills compared to the comparison group, which is what we expected. However, contrary to what we expected, the black box evaluation told us that the program didn't make any difference when it comes to diet quality. So both the comparison and intervention groups scored similarly in terms of their diet quality before and after participation in the program. And while the effect size for the food resource management skills was pretty high at 0.8 for exit and 0.9 for gain scores, for the diet quality, the effect size was pretty low and almost negligible here at 0.1. So put this finding at the back of your mind. If we were conducting a black box evaluation, this is what we would have concluded. We would have said that, okay, the program elicited improvement in food resource management skills among participants, but with regards to diet quality, there was no difference. But when we go back to our logic model and try to look at the logical and sequential relationships in the logic model, the story is a little bit different. And this is where SEM helps us to understand the mechanisms of program effect. So let me first talk about the model fit. So in the green box to my left, actually my right, which will probably be your left, you have the model fit indices, and all those indices are good. They are perfect, as good as can be, with fit indices above 0.9. And what that is showing us is that this simple model is not only plausible in our data, but also in real life. So in real life, you can expect that program participation in a nutrition education program will lead to enhanced diet quality and also food resource management skills. And you can expect food resource management skills to mediate the relationship between participation in the program and enhanced diet quality. Now, coming to the effects, the regression coefficients, and of course the mediated part, the story is a little bit different from what our black box evaluation told us. So as expected, program participation enhanced food resource management skills. And like our black box, we didn't find a direct effect of program participation on enhanced diet quality. But what we found was actually a very significant indirect effect of the program on diet quality through enhanced food resource management skills. So when you look at the screen, just by multiplying 3.0 and 0.6, we get the indirect effect, the mediated effect, to be 1.8. And the effect size for that is 0.7. And how do we get that effect size? We take that 1.8, we add it to the direct effect of 0.7 along P1 to get 2.5. So when we put 1.8, we divide by 2.5 and multiply by 100, we get 0.7. And in my experience, this is probably the highest mediated effect I have ever found. It's 70%. So it is telling us that program participation does influence diet quality, but not in a direct way. It is actually indirectly through enhanced food resource management skills, as shown in our logic model, and that this is not just an ordinary effect, it is 70% of the mediated effect. So what does this mean? This means that if we had limited ourselves to the black box evaluation without going back to our logic model to see what we had stipulated with regards to the relationships among the outcomes, we would have erroneously concluded that the program was only effective at eliciting changes in food resource management, but not diet quality. But by going back to our logic model and actually verifying that aspect of the logic model, we were able to see empirically that food resource management is a mechanism of program impact between participation and diet quality. And this enhances our understanding of how the program works, in addition to giving us empirical verification of a component of the program. So these are examples of how we have used the result. In addition to having this empirical verification, we've also been able to have a more accurate understanding of program impact. Like I said, we avoided that erroneous conclusion. And we also understand that, okay, a non-significant effect is not necessarily a zero effect. And this is the beauty of testing logic models, because sometimes when we look at the t-test, we may say, oh, there's no effect. But the fact that the effect is not significant doesn't mean that there is no mechanism going on there. And with regards to program adjustments, we have used this finding, the results, to actually renew a focus of the lessons on the units that teach food resource management, because we now know that, okay, by emphasizing food resource management, we are also giving people the skills to enhance their diet quality. So that's the end of the example. But then, I thought about what implications this could have for Cypher evaluation. Susan and I were chatting about the fact that for Cypher, your logic models are more complex. You have to show data sources, you have to show frequency of data collection and other extra information that people who typically use the Kellogg model may not necessarily need to show. So I'm hoping that this presentation elicit conversations in Cypher regarding the need for theoretical and conceptual frameworks for understanding the complexity of relationships that may be described in your program logic models. And also, hopefully, that this will ginger some conversations about rigorous designs and the use of appropriate analytical strategies. And this is not only limited to quantitative methods. There are ways to also use qualitative data to test a program model. It won't give you an empirical estimate, as you know, but it will give you a descriptive understanding of the program. And I'm also hoping that this could, elicit conversations regarding the need for studies to better understand the processes and conditions under which your Cypher programs elicit behavior changes in youth. And I do understand that, sometimes you have a program that has multiple elements, and so you may not be focusing on just one behavior change. Like in the example I have given, you may have multiple behavior changes that you expect in the youth. So some of the questions you may have, I have tried to answer here. So like Susan said, this is from a presentation I gave at AEA last year. So I tried to incorporate some of the questions I received afterwards into this presentation. So you may ask, is SEM the only method for verifying logic models? And I'm going to say, no, there are many methods that you can use. For example, our simple ANCOVA with interactions can be used to assess moderators, and regression analysis with or without interactions can also be used. Another person at that time asked me if they needed a specialized software to conduct SEM, and I'm going to say not really. Mediation analysis can be conducted in SPSS actually. However, the beauty of SEM is that it allows you to use both observed and unobserved variables, and it provides reliable fit indices. So in the example I have here, I have only used observed variables. So instead of, for example, instead of using food resource management as a summated rating scale, I could have used all the 5 indicators in an observed variable manner and would have gotten, similar findings. And another question I got then that I think people here may have is what I have on the screen about, do I need experimental data to verify a logic model? And my answer would be not always. It depends on the questions that you wish to address. So for example, when we talk about program impact, we are invariably saying that we need to compare participants and non-participants. So anything that has to do with impact necessitates the use of experimental or quasi-experimental data. But if we are only looking at relationships among the outcomes, and we are not including participation as a variable, you don't need a quasi-experimental data or experimental data. Again, if you are only looking at the extent to which outcomes were achieved without comparing participants and non-participants, you don't need experimental data. And I also got a question then that some people may have here. And the question was, can I use qualitative data to understand how a program works? And my answer is yes, definitely yes. You can use qualitative data to understand why and how a program works. And it's actually very useful for developing descriptive assessment of logic models. And I have actually used that before. And I can give a reference to that paper if some people are interested. But
Lola,
yeah, sorry.
I wanted to give you your 10-minute warning.
Okay, this is actually about my last slide. Only one slide after this.
Awesome.
Yeah, so the only advantage of quantitative data is that you get empirical estimates and model fit indices. So I will take your questions, and here are some discussion questions that we can talk about if time allows. But thank you, that's my presentation. So I have question here that says, I'm confused about the use of the word mediator variable when there is no direct effect. So, okay, I'm going to answer that question by scrolling back to that model that I shared. Okay, so if you take a look at this model, there are 3 direct paths. So the path from, just to reiterate what the question says why are we talking about mediators or a mediator variable when there are only, let me read the question out. It says, I'm confused about the use of the word mediator variable when there is no direct effect. So that's the question I'm trying to answer. So if you take a look at this model, you will see that there are 3 direct paths. The first direct path is between program participation, measured as 1 if you are in the intervention group and 0 if you are not in the intervention group. And we expected that your membership in that group should lead to enhanced diet quality. That's a direct path, that's P1. The second direct path is that your membership in that group should also lead to enhanced food resource management skills. That's another direct path. And the third direct path is that the gains you received in terms of your food resource management skills should lead to enhanced diet quality. So those are the 3 direct paths. The indirect path here, indirect path is another word for mediated path. That indirect path is the path that we cannot see physically with our eyes, but is in this model. And that is when you multiply P2 by P3. And what that is telling us is that we have program participation on one hand, we have diet quality on one hand, and in between the 2 of them, we have food resource management skills. So if I can scroll to this diagram, so we have the short term and we have the long term in this diagram. So let's replace the short term here for the purpose of explanation with program participation. And let's say intermediate, in this case, we replace with food resource management, and long-term we replace with diet quality. So the fact that food resource management is in between the 2 makes it a mediator. I hope I have answered that question, and I can take more questions.
I see a few cameras being turned on. Come on, don't be shy, Cypher.
I have one. Hi, this is Josset Gale from University of Wisconsin-Madison. I love this. Thank you so much for your presentation.
Thank you.
One question I have, because I've always thought of doing this, but many times our program participation numbers are very small, like less than 100 youth. And I always have concerns about statistical power and how many participants I'd actually need to have the power to run an SEM like this. Can you talk about how to deal with that kind of issue?
Okay, so generally speaking, you know, if we're having 1 to 2 to 3 regression paths, anything between 50 and 100 will be good. But if the paths begin to go beyond that, then we begin to lose power. So, but there are people who are more conservative than I am, and I'm going to tell you that for every path, you should have 20 participants, 20 data points. But you know, it depends on, you can find literature to support both groups. But what I would say is that if you can find a calculator to do the power analysis, you may want to try that, but you may not need as many participants as you may think you need, depending on the complexity of your model. So for a model like the one I shared, I'm sure I can successfully run it with 80 to 100 people, or maybe even 60 to 65, because remember, I only have one mediator apart from the control variables. So, but if the model begins to, if it becomes more complex, then you will need more data points. Did I answer that question?
So there's a question in the chat if you have a recommendation for good text on structural equation modeling.
I really do like the book by Abounds. I hope I'm not messing up his name. And there's another one by Klein, Bolen and Klein, but I typically refer to it as Klein. I believe he's a Canadian, I'm not 100% sure, but that's a very good book, and the one by Abounds. And there is a journal of structural equation modeling that is very good. And I think somebody's from Ohio State here. You have David McKinnon, I don't know if I'm saying his name correctly, and Dr. Preacher. They do actually have a website dedicated to structural equation modeling and path analysis. So they have written very good books. I don't remember the title of their books, but they are very good books. But I love Klein, and of course the book by Abounds.
We'll connect maybe, and then we can add these references to the website so that folks know where to find these.
Yes, I can send you an email with a list of those references. Yes.
Yes, thank you.
And one thing I may add is that if you're thinking in terms of software, there are different softwares for running structural equation modeling, but the good news that came out of recent, maybe in the past 6 or how many years or more, is that Amos was purchased by SPSS. So they now integrate very well into each other. And SPSS is easy to use, just like most people prefer. Amos is easy to use, easier than Stata or SAS or HLM for SCM. And you can click and drag, and you can draw out your model in Amos, and now it integrates beautifully into SPSS.
Thank you. Well, Nancy, go ahead. You're the last one.
Okay, thank you, Lola. I really appreciate this, and it gets me just thinking and getting excited about SnapEd in our own state, for one thing, but also for the Cypher project now, the Juntos 4-H. And I don't know the Juntos evaluation tool yet, or what, so I need to see. Are you aware of Juntos? And have you looked at what? Okay, yeah, because I think that maybe we'll be reaching out to you down the road here to see how we can make this work for that too, because I really can see the benefit of this. So thank you.
Thank you. So I got a lot of messages while you were talking. I just wanted to appreciate everyone that sent me a note. I won't be able to respond to every one of them because this Zoom link will be deactivated soon. But thank you everybody for your comments, for your positive comments. I really appreciate your comments, and thank you for inviting me, Suzanne, and thank you everyone for listening.
I agree. Thank you, Lola. I'm sure we will be in touch soon. I really appreciate it. I enjoyed it just as much as I did in November. So thank you. Thank you, Cypher, for joining.
Thank you.
Thank you.